Okay, let's unpack a very specific infrastructure headache.
One that I think a lot of our listeners have probably run into.
I think so. So you're setting up digital signage, maybe in a huge space like an airport or a mall, and you're dealing with DVI.
Ah, DVI.
Yeah.
It's legacy hardware, for sure, but it's just so stubborn you still see it everywhere in industrial setups.
And the problem is always, always the distance limit of copper.
It's the classic bottleneck. You run a standard copper DVI cable too far, and the signal it completely disintegrates.
You get that flickering, the snow, or just nothing, a black screen.
Exactly.
But today we're diving into a piece of hardware that sort of looks at that copper limit and just sidesteps it entirely.
Right. We're talking about the NTI ST-1FODVI-R-SC.
It's a DVI splitter and extender, but the key here, the whole reason we're talking about it, is that it swaps copper for multimode fiber optic cable.
And that shift to fiber is the entire strategic advantage. So our mission for this deep dive is to figure out how this thing manages to push high-quality video, a full 1,000 meters?
A full kilometer. That's over 3,000 feet, all without losing signal integrity.
And it does this using NTI's VOPEC splitter technology to drive these huge digital displays.
Okay, let's start with that range, because 1,000 meters is a serious, serious run.
It really is.
Normally, you're lucky to get, 15 feet out of a standard cable before you need some kind of repeater.
And this distributes high-resolution DVI video to up to 4 different displays at that full 3,280-foot distance.
And the resolution holds up.
Oh, yeah. It handles up to 1920 by 1200, so WXGA. The image stays perfectly crisp.
And that's all because of the medium, right? It's using that single-strand SC multimode fiber.
Specifically 50-micron cable. So instead of these heavy, bulky copper wires, you're running this thin strand of glass.
That seems like a much smarter play for the infrastructure itself. You're basically future-proofing the installation.
The form factor supports that, too. The actual transmitters and receivers are tiny.
How small are we talking?
Roughly 1.5 by 2.5 inches. So you can run the thin fiber cable through conduit first, which is easy, and then just attach these little units at the very end.
Which solves that whole logistical nightmare of jamming bulky connectors through tight spaces.
Exactly.
Now, aside from just distance, the move to fiber solves that other huge industrial problem, interference.
Yeah, zero RF interference.
Because you're moving photons instead of electrons, so you're effectively immune to all that RF noise you'd get on, say, a factory floor.
You're completely bypassing the electromagnetic spectrum. A copper wire basically acts like a big antenna. It just soaks up noise from lights, from machinery, you name it.
And this system uses, an 850 nanometer VCSEL source?
That's it, an 850 millimeter VCSEL optical source.
Okay, so for those of us who don't speak laser engineering, VCSEL is a specialized kind of laser diode?
It stands for vertical cavity surface emitting laser. It gives you the speed and efficiency of a laser, but it's cheaper to manufacture than the traditional ones.
So it keeps the cost down.
Right. And it's all laser class 1 safety compliant, so in a noisy environment, your signal is just pristine.
Reliability is everything. Now, NTI calls this a VOPEC system. That's their branding for their splitters, correct?
It is, yeah. The setup is pretty simple.
Yeah.
You've got a transmitter at the host computer, an optical splitter, and then those long fiber lines running out to receivers at each display.
Okay, next question is always power. The transmitter by the PC is probably fine, but what about the units 1,000 meters away?
That's another neat feature. The local transmitter actually draws its power right from the computer it's attached to.
Oh, that cleans up the rack nicely.
It does. The remote unit, however, does need its own standard AC adapter.
Which makes sense. I also saw on the spec sheet it has EDID learning. That seems critical for avoiding those handshake issues.
It's huge. It basically captures the display's data.
Yeah.
So the host PC never thinks the monitor has been disconnected. It prevents that common headache where a screen goes black after a reboot.
So it's like insurance for the signal path. And it's DVI 1.0 compliant, so it'll play nice with existing gear.
And when you look at the price, it's around $580.
For a professional setup, that's a pretty strong value proposition.
I mean, compare that to the labor and hardware costs of running copper with repeaters every 50 feet. A single clean fiber run is way more efficient.
Plus, it's got a 2-year warranty, which shows it's built for those mission-critical jobs where failure just isn't an option.
It really just transforms how you think about the geography of a setup. You're not tethered to the computer anymore.
You're pushing video over a kilometer using light.
It's a really smart evolution of the tech.
So here's a final thought for you to chew on. We usually think of infrastructure as just pipes for data. But consider this. Replacing copper with fiber doesn't just extend your range, it completely eliminates the invisible noise of electromagnetic interference. In a world that is getting electrically noisier every day, sometimes the best way to be heard clearly is to just use light.
Thanks for listening to this deep dive.